from System Coding Club Embedded Subsystem. Today, under microcontroller and sensor integration, we are going to see a small concept called PID, proportional, integral, and differentiative. So, what makes a pacemaker keep a heart beating or a drone balance in midair? That is embedded system. In case of heart beating, like pacemaker, we have a small sensor which detects the heartbeat, and the microcontroller gets its data and checks whether the heartbeat is in a desired level or not. If it is not, then it is gives data to the actuator. In this case it is actually electrical pulse. This makes sure that heartbeat is in desired level. In case of drone, we'll use a IMU, like it contains accelerometer, gyro, and magnetometer. This raw data is converted into roll, pitch, and elevation. Using this data, we can actually perform many tasks, but simply we can just do balance in midair like hovering. So first of all, why we need embedded system? Like we can see things around us, we can feel stuff, but in case of robots or machines, they can't. So we need some form of module which converts the physical data into electrical pulse such as voltage or current. So sensor are basically which converts physical energy to electrical energies. So then so for explaining PID, I will just go with the really basic line following board because it's like only 1D, like one dimensional. So like first of all, why we need this kind of bots? So if you consider line following bot, it's a like really basic version of AGV, automated guided vehicles. So these can be used in warehouses and factories to transport goods in a predefined way or path. So next, like this concept is like beginner friendly, like no prerequisites required. Like I have attached two links for line following bot as resources. Then actually this is a circuit of a line following bot. If we consider here, it is a 5 IR array module. This one is like basic Arduino Nano. We have Bluetooth module, motor drive TB66, and N20 gear motors. Like this is buck converter and lipo battery. Why we are using Bluetooth module is like for PID we need to change constants, so it will be really helpful at end. I'll just show you afterwards. Then okay. So what is PID? Proportional, integral, and differentiator. So like first, if we consider this as the white line as a line which we are desired to go, and this blue color as a 5D array. So we have IR sensor at all these positions in the red dots. So if you want to calculate error, so I'm considering like 5 minus 1 into K1 plus 4 minus 2 into K2. Like K1, K2 are weights of this value. Like if I want to follow the line, if the line is like in the 5, I'll give like I should turn more right side. So K1 and K2 will act as weights. Okay, then okay. Okay, like this one is a graph only if we use proportional. Like consider this one is here. It like my mouse cursor as line. If it is here, like error should be 0, so I will just move straight. If this line is like sorry, if this line is just moving towards somewhat right, then my bot should move towards right, so it will like balance this action. So that is like proportional. I will just take this error and multiply with some proportional constant, so it will move. But in that case, what will happen is like consider it is like away from line, like SP as line. It is away from line. Now it is going. Like it is overshooting. Then it will again try to come back. As the error is decreasing, so the proportional value will also decrease. So it will have some steady state error. We can't like accurately get a desired value. In case of integral, what integral does is it will add all the previous errors. So it is like the duration. till till when the error is there, like duration of the errors. So it will decrease a steady state, but it will take some time. In case of differentiator, what it does is it will just check the rate of error change and tries to minimize this overshooting and those things. So PID control is like really best one. So it will like just go up, overshoot, like little bit overshoot, then it will get its desired value. And so like a quick question, what is the main function of the integral terms? Guys,
Like as you said, it will add up all the errors and it will somehow reduce the overshooting.
yeah, no, it will not reduce the overshoot. It will actually see here. If you use proportional first graph, if you use proportional integral, then second graph. Like what is the like difference between these two graphs?
There is a decrease in the PV value, like compared to the previous one.
Sorry, can you repeat?
There's a decrease in that graph. Like if you consider the
Yep.
SP line, it is
Mm-hmm.
more. The graph is more near to the SP line in the second graph.
Yeah, SP line
In
is a desired value. This graph is our output. So we are like, if you use only proportional, it will have some steady state error. In case of if you use proportional and integrated, we can reduce this steady state error, but it will take some time. Okay.
okay,
So the answer is B. What does the derivative term do? Like respond to, sorry. Actually, this one is easy. Derivative means rate of change. So C. So like, so what is the disadvantage of proportional control? Like only just using proportional.
B, right? Oscillates forever and cannot eliminate.
Sorry.
It oscillates, right?
C.
B, right?
No, not B. Actually, like if you see here, if you use only proportional, we are not oscillating like always. Like we are getting like after 4 or 5 oscillations, we will get the value, but we can't get the same desired value. Like there will be some error if you use
Okay.
only proportional. So we can't emulate the steady state error. So actually, yeah, just a second. So I just have a quick pseudo code of the line following bot. So if you see here, we will declare like I think most of you guys are familiar with Arduino IED because like you're almost 1 year after. So we are using global variables like whatever variable you need to declare. Void setup, we will just run once calibrate sensor, like it will make sure that if there is any hardware error in the sensor, it will make sure that it is calibrated. So in the loop function, like in Arduino IDE, the loop runs always, like it will keep running. So first one is wait for start. It will just make sure like if you have some button after you press it, the bot starts. Navigate till the endpoint. So in navigate to the endpoint, we have three functions inside: follow line, check node, and change direction. In follow line, okay, follow lines use PID. It will use PID and move in the line. After that, it will like first the bot is there. It will just follow line for some like consider like 2 milliseconds. After that, it will check node whether there is some T joint or like 90 degrees turn or some U turn or stuff like that. If there is anything like left or right or U turn, it will next command will go to change direction. Okay, then the preference order is left, straight, right, U turn, and till end point. So while the bot is going in the line, it will know the directions. Like there will be an array where it will store left, straight, like stuff like that. In which direction it is going. Then then there is a small algorithm which will actually reduce the path, like bot. So this algorithm helps like U-turns and those stuffs. Then after simplifying it, will run faster, like in the more optimum path. So actually, just a second. Okay, fine. So consider this as like our maze. Okay. First, the bot will come from here. Then, as left is our first preference. Okay. The bot comes from here. As left is our first preference, it will cut left. Then it will check for node. There is no node, so it will take U-turn. Then again it will go left. So if we see here in the code, left, U-turn, left. We can replay. First, it will run this one. It will check for left, U-turn, left. Then it will replace with straight. In the next, like after you complete the full maze, if you run for the second one, it will not go for left, U-turn, left. It will directly go to straight. Then if we consider like T joint here path is there. Here it's useless. Okay. First it will go straight. So left, U-turn, left, U-turn, then left, then U-turn, again left, left, U-turn, left, U-turn, left. Then it will come like in this direction. So left, U-turn, left. If you see in the code, first it will run once. So it will see left, U-turn, left as straight. So this one will convert as straight. So it will be straight, U-turn, left. If you see in the third line, straight U-turn, left is converted into right. So effectively, all this part is converted into right. After it comes to this node, it will just turn left, right. Okay, then. So are you guys clear with this one? Okay. So, in embedded system, like we have many projects, starting from drone, robotic arm, line following bot, micro mouse. Then we have like a pacemaker, many other stuff. All electronics can be like most of the electronics are embedded system only. Like almost everything. And so if you see the career prospects in embedded system, like we have plenty of them: embedded software designing, hardware engineer, IoT engineer, robotics engineer, automotive engineer, medical device developer, like much more. Actually, if you consider embedded system, it's one of
Jagadeesh,
the
the
core.
slides are not visible. Hello, I think the slides are not visible. Are you presenting the slide right now?
Just a second. Yeah.
The slides are not visible actually.
Yeah. From where it was not visible.
I think the future, like you were talking about the future
Yeah,
of
okay, okay,
embedded
then
system,
okay.
right? Um,
Now it is visible, right? Career prospects in embedded system PPT.
no,
Yeah, okay, just a second, wait. Now,
Yes, yes.
yeah, okay. So if you see the career prospects in embedded system, like there are plenty of them: embedded software developer, hardware engineer, IoT engineer, robotic engineer, automotive engineer, and medical device developer. Like there are plenty of jobs in embedded system. If you see ECE, one of the core job is embedded system. Like you have plenty of other also, like many like VLSI and those stuff also. But embedded system is also like one of the core jobs you get. So like if you planning to learn this one, just you should be like really strong with C programming. Then actually what I recommend is first you should know C programming, then you can jump to Arduino, then you can go for RTOS, real time operating software. Like most of you guys should be good in digital electronics, like it was in third sem I guess. Then computer architecture, this one you should learn like somehow. Like this one is really good. It will make sure that you will develop whatever embedded system you are developing is in most efficient way. Then you can jump to projects, like I have included this YouTube video career for embedded system. And if you have any question and answers, please ask. So, which microcontroller should we learn? Like, if you are really starting right now, then you can go for Arduino, which is really user friendly and which is easier. Then you can like either you can go for Arduino or ESP. Then you can jump to STM. STM is really good. In most of the industries, they are currently using that only. Anything else? Yeah, Arduino, ESP or STM, or you can go for like directly to ESP and STM, no problems. Yeah. So no other questions.
When will you play Halo? When will you play Halo?
Huh? Sorry, Harith.
Is it possible to play
Is
games
it
on
possible
embedded
to play games
systems?
on embedded systems? Like what type of game?
A shooter game or
A
something like
shooter
that.
game or something like that. No, no, no. Like you can just play like that 2042, those kinds of game maximum. That's all.
Okay, okay, fine.
Okay, okay, fine. Yeah. No other questions. Fine. Okay. Just a second. So you can connect with us like we have a LinkedIn account, but I think there's some problem with that one. You can contact any of our member club members. Then thank you. If you have any feedbacks, you can just scan the QR code, Google form,